In this video, we are going to look at average rates of change. You may have already studied this video here, which shows when water is poured in at a constant rate into different vessels. You can look at the graph on the right, which represents the height at any time within each vessel. Now we're going to look at this average rate of change on this graph here. So at the moment, the red line here shows constant rate. Now, when we're working out the rate of change between 2 points, particularly on a straight line, we'll already be familiar with rise over run because that's the gradient. That is the difference in the y direction over the difference in the x direction. So now let's look at some examples of average rate. For example, if we wanted to find the rate at which a tree was growing, we would select two heights, of course with corresponding times, and we would calculate the average rate of growth, as we know it's not constant. And to do that, we'd use rise over run, which I guess in a sense with this particular example, looking at change in height between those two times that we recorded, divided by the time, the change in time. And my second example is just to do with this graph. We can see it's a distance time graph, and the red line is the distance travelled over time, and we have two coordinates P and Q. If we want to work out the average rate of change between those 2 points, we'll actually be calculating the average speed. So if we do that, we have some coordinates here. So this coordinate is 748 and this coordinate here is 230. Okay, so the average rate of change here is going to be 48 minus 30 divided by 7 take away 2. 18 over 5, which is 3.6 meters per second. Okay, on to example number 3. We're going to find the rate of change of height between t in minutes, between 1 and 3. So we can see here that we've got the height or the distance in meters. So we're interested in this height here, so let's highlight here and here. Okay, so the average rate of change equals, so the y coordinate will be here, which is d, so this is your x and this is your y, so it's going to be 130 take away 60 divided by 3 take away 1. Okay, which is 70 divided by 2, which is 35, and the units are meters per minute. Okay. All right, and finally, example number 4. Over a period of 6 hours, the temperature of a room is described by the function here highlighted, where T is the temperature in degrees Celsius after 8 hours. So first, we want to find the initial temperature. In order to do this, we're trying to find the temperature when number of hours is 0, so when H equals 0. So I'll do that first. Sub that into the formula. T equals 0 minus 4 times 0 plus the 22 equals 22 Celsius. Okay, part B says sketch the graph of the function over the given time interval. So in order to do that, I need some values. So I'm going to substitute h equals 1 into this formula, h equals 2, h equals 3, and I'm going to go all the way up to h equals 6. So I've got a table of values so I can plot the graph. So I'll do that now. Okay, so there's my table of values. Now on part C it says draw a chord between the points h equals 1 and h equals 5. So once I've sketched the graph, I'll be looking at the point here, h equals 1 and h equals 5. Okay? Okay, so to sketch, obviously I'm on the class pad. I'm going to go to main menu, graphs and tables, and I've inputted the function in here. And I'm going to plot the graph now. There we go. I'll just copy and paste that into the screen. Okay, so here's the graph. Right, so I want to draw a line between 1 and 5. So I guess this is just visualizing, because I have a table of results, what this is going to look like. So 1, 2, 3, 4, 5. There we go. There's the line. That's the chord. Basically, what we're doing here is working out the average rate of change. So let's take the gradient between here and here, and we know what those coordinates are because we can see on the table above. So the average rate of change equals 27 minus 19
divided by 5 minus 1, which is 8 over 4, which is 2. Now, if we're going to interpret that, which I think is what part E is asking us, what's the average rate of change of the temperature, then what that's asking us to do is to interpret, so that's part D. It's asking us to interpret, so we want to use units. Now, we were dealing with height in meters. No, we weren't. Apologies. We were dealing with hours, and we were dealing with... So what we can say is that's 2 degrees per hour. I'll write that. So the rate of change is 2 degrees per hour. Okay. Okay,